What is up, everybody? It's Cameron from Tinybird, and this is our second installment of Tinybird Builds, where we build things end-to-end live. We use a lot of AI tooling because that's what we're all doing these days, and usually we're focused on sort of data-intensive things. If you want to follow us on Tinybird Builds, we have a separate YouTube channel just for this, so you can subscribe to that. If you're watching on YouTube, do that now. By the way, new swag just dropped. I think it's awesome. If you subscribe on YouTube, one person, I'll find one new subscriber on YouTube and they'll get this hat. I'll send it to you for free. So do that. And by the way, don't subscribe for me. The build today, it'll be fun. But the real meat is actually happening next week. So next week, we're going to, Javi Santana, our fearless leader, is going to do a live build showing how to ingest 1 billion rows per second into ClickHouse. So if you care about ClickHouse, if you care about performance, if you want to see something cool happen, I would recommend you subscribe so you can join that one. It's going to be really good. But today what we are focused on is kind of the idea was, how do you build dashboard filters across many dimensions? And it's pretty easy to filter a dashboard on a single dimension. That's a pretty basic analytics use case. You can use sorting keys and indexes. But when you start to add many, many dimensions on top of that, and you want to sort of do cross-dimensional filtering, that's where you can have performance problems. And so we're going to work through that a little bit today. My goal is to kind of first things first, get a working build, and then we'll kind of try to layer on performance improvements as we go until I, run out of steam. But today I'm gonna let me share my screen here. So I am working off of the Tinybird Web Analytics Starter Kit. So if you're not familiar with the Web Analytics Starter Kit, this is our most popular template, and it is a kind of a basic web analytics dashboard that you can use as is. And actually, here's kind of a demo of it. This is what it looks like. We recently updated it, so it's got some nice new things built in. Obviously, the Ask AI features. You can just ask anything of your data and kind of get some custom tables, get some custom metrics, which is pretty cool. We've updated the styling. We've added support for multi-tenancy. So if you want to sort of extend this to use in your SaaS app, where you have multiple users, multiple tenants, you can do that and kind of bake that in. I'll explain that a little bit more in a bit. We've also added the ability to sort of filter by different subdomains. So you've got that. And then we've kind of refreshed the dashboard. So it's pretty cool. I like it. This is a demo we're going to be building locally today. So I'm going to shut this one down. This is my local workspace. But if you want to use this, you can just fork this GitHub repo and start working. So feel free to follow along if you want, or just know that you have this. It's a great, analytics starter kit. If you just want to monitor the analytics on your website, you can deploy it in like a minute. That's great. But today we're going to focus on cross-dimensional filtering, and let's kind of jump in. I'm gonna pull up cursor here. So I've already cloned this in. You can see I've got Tinybird local running. And actually that's the URL here. And I haven't built it yet. So let's just go ahead and TB build. So this is going to build the Tinybird project on my local Tinybird local. So it's deployed all that, and now it's built. If I head back to that UI, boom, you can see that it's built. So this is the Tinybird UI, and it's showing me my local environment. And it also includes a fixture, so you can actually see its appended data. And so let's actually run the dashboard. So the dashboard is simple Next.js app with React components. So we're just going to run it on localhost, and let's go open that up. Let it load. Okay, cool. All right, so the first thing you see when you open this up is you get prompted for a workspace admin token. And this is kind of supporting those multi-tenancy features. So when you access the dashboard, you use a signed JWT, and that JWT is scoped to a particular tenant. And actually, I think the sample data that I have, it has like a tenant 1 and a tenant 2. So you can actually, we could put in tenant 1 or tenant 2 here. I'm just going to leave it blank. It'll basically default to a tenant, but we can go get our workspace admin token. So I'm going to go do that. By the way, this is a local token. It's not exposing anything. Don't worry, don't freak out. It is ephemeral, and you can't access anything with it. But when I put that in, it's going to allow me to view my dashboard, and you can see the data. So this is all running locally. I've got my Next server running my front end, and then I've got Tinybird local running my analytics backend. And I think it's got like 1,000 rows of data in here, split across tenants, split across subdomains, things like that. So you can see this is kind of the basic layout here. We've got, sort of subdomain level filtering, so I can click a subdomain, and it is filtering by tenant using that JWT. And if we open up the dev tools, we can actually go to the network tab, and like when I change the time, you can see those Tinybird APIs being called. So for instance, top pages API, payload, here's what it's providing, the query parameters that it's providing, and then the response kind of looks like this. So we get for the time range that we've selected, we get the number of kind of visitors, page hits, and then kind of previous data and the difference in that. So that's what we're seeing in these API responses, very similar for top locations, top sources, and that's what's powering all these little components here. So what I want to do, so right now, the only dimensions that I can filter on are subdomain and time. And that's fine. I can get some level of insight from this. But what a lot of people will want with a dashboard like this is to be able to do sort of cross-dimensional filtering. So for example, if I wanted to see, all the people who, viewed this blog post from the United States coming from Hacker News, right? Like that's the kind of filter that I would want to be able to do. That's going to give me the insight that I want. And right now, this template doesn't support that. I use this template personally in my job. It's something that I use. And so this was the first thing I identified as like, I want to be able to click on a thing and filter it. And so that's actually what we're going to build. We're going to build a click to filter feature on this dashboard. And I'm going to use Tinybird code to do a lot of backend work. If you're not familiar with Tinybird code, it is an AI agent CLI. We kind of call it our AI ClickHouse expert. And it's really, really good at kind of, high performance data engineering. It's like Claude Code, but it's really focused on the kinds of things you do with Tinybird. And so we're going to use that. I'm going to use Cursor for the front end. The front end's basically a one shot. I'm not really focused on that today. What I'm focused on is kind of this back end. And focused on giving us that ability to do cross-dimensional filtering. So one thing I want to show before we kind of jump in, let's go look at the lineage of this project. So I know it's a lot. There's a lot of stuff going on here. We are going to focus on kind of this tree right here. So we have this raw analytics events data source. That's where all the raw data comes in. It's kind of semi-structured. So we have a big JSON payload that gets attached to that. You can actually go and kind of see what the schema looks like here. So we have timestamp, session ID, action, and then this payload column, as well as the tenant ID and domain. And this payload column is just a big JSON string blob that has a lot of various different data in it. And then we do some initial parsing on this analytics hits endpoint. This is actually a really nice feature of Tinybird, is just the ability to sort of reuse SQL. So we have a lot of pipes that will use this analytics hit endpoint. And all this is really doing is just, extracting stuff from that payload. So it's getting things like domain, locale, location, refer, path name, all that kind of web analytics stuff. It's doing some parsing on the user agent. So telling me, what kind of device, what kind of browser, things like that. And then it's sort of exposing that data as an endpoint, which other pipes can then use. And so we can see a few things. So we've got these three APIs, we're not going to touch these today. These are kind of showing, distinct domains, live visitor count. There's a trend as well. That's kind of like a real-time trend. We're not going to touch that. But we have a few materialized views here, sources, sessions, and pages. So these are basically materializing data for sources, sessions, and pages, as the name implies, and then storing that data. So we could actually, let's go look at the analytics page, materialized view. You can see the schema, but basically for a given date, tenant ID, domain, device, browser, location, path name. So for any page, it is telling us the number of visits. It's aggregating the number of visits and hits. So it's kind of pre-calculating those aggregates for that page, for that date, kind of for this level, and then it's sorting by these things. So you can kind of see what this looks like. So on date, July 28th, we have domain, device, browser, and then these aggregated states. You merge these at query time. We'll get into that a little bit later. But that's kind of what we see there. And then on top of those, these are the APIs that we are really going to focus on. So these are the APIs that really power that dashboard. And what we want to do is we want to update these so that they support cross-dimensional filtering. So if we actually go and look at one of these, I'm just showing it on the UI. We're going to open up Cursor here in a second. Pretty complex SQL. I know it looks probably looks more complex than it is. If you're not familiar with Tinybird pipes, basically the way they work is you can write your SQL, you can break it up into different nodes. So you can see we have kind of different nodes here, 1, 2, 3, 4 nodes. And so those nodes can sort of query off of prior nodes. The way that this pipe is working is it's getting sort of top pages, current pages, and then top pages in the previous time period. So it's kind of providing a comparison. But then there's a lot of filtering in here. We use this filter logic. For example, this is actually a node that just generates a time series. So it's just looking at the supply date ranges, and it's generating a time series that we can then populate with the data. And then we're getting current period data, previous period data, and then sort of joining it all up into this final endpoint. And you can see, I think worth calling out these filters here. So for example, let's zoom in on that a little bit. If the tenant ID is defined, we filter and we say, only return data where tenant ID equals this tenant ID. And since our dashboard uses a JWT with a fixed parameter that sets that tenant ID, when we access the dashboard with that token, it's only giving us access to that tenant's data. Same thing with domain. If I select a domain here in this dropdown, it's going to pass that filter. And so that's how we sort of define query parameters in a Tinybird pipe. So we're going to be kind of expanding that today to include more filter parameters and things like that. So let's jump into Cursor. Let's start building. I'm using Cursor. I'm gonna be using Tinybird code. I'm just gonna kind of use the built-in terminal here to keep it all in one place because I think that's a little bit easier. And so before we get started, first of all, we're just gonna start Tinybird code. So I'm gonna get that up and running. There's a new version available. Yeah, sure, let's do it. YOLO, So we're gonna run Tinybird code. It does not render very well. The ASCII does not render very well. Can I spread this out? There we go. You recognize that? Okay, see, that's where it's coming from. So this is Tinybird code. I am out of credits, but thankfully Tinybird is footing the bill for these right now. So we're going to use Tinybird code. This is going to be kind of how we interact with Tinybird. And before I change anything, I am going to check out a new branch. So I'll call this I'll just call this cross-dimensional filter. All Tinybird resources are defined as files. So we're version controlling here. Software engineering principles apply. We're making changes to an endpoint. We're going to use version control. So I'm checking out a new branch. No surprise there. So let's go back to Tinybird code. And what I want to do, since I'm going to be changing these endpoints, the first thing I want to do is actually build tests. I'm going to be changing the data pipeline that serves these endpoints, but I don't actually want the output of the endpoint to change. I don't want to have to change the front end to support a new API response format. I just want it to work. And so to make sure that I don't break anything, I'm going to build tests. So I can do this with the Tinybird CLI, but I can also just ask Tinybird code to do it. And so that is what I'm going to do. So I'm just going to say, build a test suite for the endpoints, use the data in the fixture file. Note that today's date is, what is it, August 27th, 2025. Why am I telling it that? LLMs are terrible with dates. They never know what day it is. And so I've just found that what it's going to do is it's going to sort of build these tests with different filter patterns and things like that. And since the data that I have is kind of in the last 30 days from today, I'm telling it like, hey, here's today's date. So it knows how to build those filter parameters. So let's let Tinybird code go off and chirp. And so what it's going to do is it's going to hopefully build these tests for us. Yeah, takes a little bit. Okay, here we go. So I'll build a comprehensive, so blah, 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 blah. Ooh, delegate. So, okay, this is important. This is fun to call out. So you can see, let me delegate this to the test management system. So Tinybird code actually is like a multi-agent system. It has some sub-agents built in to handle different tasks, and test management is one of those sub-agents. Okay, so we have our first test file, and I'm just gonna really quickly go through this. But what it is doing is it's building like tests for sort of common or expected query patterns. So for example, default last 7 days, it's saying this is the default behavior, no parameters. This is the data that it expects. That is based on this fixture file that comes with the repository. So you can see this is kind of sample data. That's what's getting loaded into the dashboard, and Tinybird code is generating tests for that. So it's got all these different tests. Some of them have parameters, and it's just kind of running tests for all of the possible query patterns to try to check for edge cases as much as possible. So it's saying, do you want me to go ahead and create this YAML file? I'm going to say yes, and it's going to build that in this tests folder. And so there we have it. So, it's like anything, it's a YAML file. So you can actually run this with the Tinybird CLI. You can also run it in CI/CD. That's the more common place when you're actually getting into a production workflow. You're changing production endpoints, you define these tests, and then you run them during CI. So it's doing the same thing for top pages. We're just gonna kind of chunk through these. But you can see what it's doing is it's building the tests, running the tests, making sure they all pass. That's kind of what we want to see. And so it's going to continue to build this test suite for all of my endpoints. And while it does that, I'm going to vamp a little bit because this will take a little time to go through all the tests, but this is kind of good hygiene as I'm working on something. This is something we have in production. So I don't want to break anything. But just a reminder, Tinybird Builds. This is a new YouTube channel we just started. If you're watching on YouTube, you can subscribe right now. If you're watching on LinkedIn or Twitter, you can go to YouTube and subscribe. If you just go to tbrd.co/builds, that will take you to the page we have where you can see all the builds and see the upcoming builds, and you can subscribe to the channel. So tbrd.co/builds. Okay, we gotta keep telling Tinybird code yes to finish building these out. I'm gonna adjust this sidebar so y'all can see everything. That's better. All right, we're gonna keep going. So it's going through all these APIs that are supporting this dashboard and building these tests. I'm gonna get a sip of water. And this actually feels like a good time to kind of take a step back and maybe explain what Tinybird is. If you're unfamiliar with Tinybird, Tinybird is a managed ClickHouse specifically for software developers, AI native developers. Tinybird is really a platform that is built on top of the ClickHouse database. And it provides a bunch of other things on top of the database that make it really, really good for integrating ClickHouse into your application. So ClickHouse, if you're not familiar with it, is an open source analytics database. Very, very powerful. A lot of people use ClickHouse as like a data warehouse. You can use it for like your observability stack. It's really good at sort of analyzing and processing logs. We have some templates for that as well, if you're interested. But it's also a great sort of analytics application backend. So you can almost like an application database for OLAP workloads. And if you're using it for that use case, if you want to take ClickHouse, you want to integrate it with your application, Tinybird is the best way to do that. Put simply, Tinybird is the best way to do that. Fastest, cheapest, most fun. Performance is amazing, but Tinybird gives you the tooling to integrate ClickHouse into your application really, really fast. Like most people who use Tinybird for that use case, they have their first feature in production in like a week. I'm not lying. That's not an understatement. So yeah, we are almost done with all of these tests. There's a lot of endpoints here. Maybe I could have been specific about just the endpoints I was running, but that it's building a comprehensive test suite. I think that's good to have in anything. But yeah, that's Tinybird in a nutshell. Let's keep going with these tests. We're almost done, y'all. Test suites are important. Nobody likes doing them, but at least the AI is building them for us. And it does a really good job kind of covering all these different edge cases. If you have any questions, by the way, you can drop them in the chat. I will reply to them as I see them. Feel free to do that. This is taking longer than I thought it would. Don't worry, we're going to have a very comprehensive test suite when we're done. Tell you what, let me look. Let's see. Browsers, devices, locations, pages, sources, and KPIs are all done. We have the tests that we need for the endpoints that we're going to mess with today. So if it tries to make more, I'm just going to stop it. And we'll just roll with the tests that we have. All right, let's just cancel. We're gonna do what we've got here. All right, so we have tests. Now we can run those tests. So we can ask Tinybird code to run those tests. But what we'll do when we edit our APIs is we can run those tests again. Just have Tinybird run them for us, and then kind of make sure that we haven't broke anything on our API. So now let's get into the fun part. Let's actually build these cross-dimensional filters. Anytime you're working with an LLM or an agent, context is king. Everybody knows that. The prompt matters. The context you provide matters. Tinybird code is really optimized to use your data and your resources as context. There's obviously a lot of sort of knowledge behind it about ClickHouse and how to implement ClickHouse, how to implement Tinybird. It's obviously optimized for that. You can launch right in when you use Tinybird code. There's a YOLO mode kind of thing. I mean, you can launch right in. But what I have found is that it's always good to document the plan. That way, if your session gets interrupted for whatever reason, you have sort of this markdown file that you can point the agent at and say, hey, this is what we were working from. So I'm going to ask Tinybird code to create a plan. And so what I'm going to say is, this is a data project to support a web analytics dashboard. Right now, the APIs only filter on a single dimension, but I want to add cross-dimensional filtering so that all of the dashboard APIs, and I'm going to be specific about this because there's some that we're not using. So it's KPIs, top pages, top sources, top browsers, top locations and top devices, so that all of the dashboard APIs can support filtering on one or more dimensions. And those dimensions would be, path name, location, device, browser, and refer, in addition to, tenant, domain, and time range filtering. So I'm going to ask Tinybird code. So I want you to create a plan.md file. So it's just going to create a plan, create a markdown file with this plan, with a plan for how you will implement this cross-dimensional filtering. One of the things we can tell, we can sort of give it like, design guidance. So for example, what I will say is, in your plan, focus on a working version first, even if not optimized, and then provide a future optimization path for performance, something like that. Basically just saying, hey, we're gonna take this in multiple steps. We're not gonna just try to one-shot this from the beginning. My goal is to get a working dashboard that can do kind of cross-dimensional filtering. And Tinybird is really fast. These analytics are really fast. So unless you have a really big website, these APIs are going to be fast, even if you're querying the raw table. Once you start to really get into, big amounts of data, and by big, I mean 100 million rows plus, that's when you'll really maybe want to start thinking about optimization. So, scale when you need to, optimize when you need to. Don't optimize too early. And so that's kind of what we're going to focus on in this plan. So I'm going to let Tinybird code take that prompt, and hopefully it will create a little plan markdown file that we can look through. By the way, this there's no time limit on this. I'm not going to cut myself off after an hour. I think anytime you're using AI agents or things like that, you're kind of dealing with non-deterministic output. I'm going to get as far as I can and as much time as I think is reasonable. If you are watching this, great. If you want to hop off, great. You will obviously have access to the recording. And then we're also going to kind of take the recording and sort of slice and dice it into a nice little, 10 to 15 minute summary, so you can get the high points if you want to later. That will be available on the YouTube channel. All right. So Tinybird code has created this plan, and it's a pretty comprehensive plan. So I'm not going to read the whole thing, but let's kind of skim it. So this plan outlines, blah, 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 blah. Currently APIs filter, we need support filtering. Okay. So it understood my requirement. Here are the existing APIs. It's showing me, here's the data architecture. So it's raw data from analytics hits, as we talked about, is parsing that analytics events data source. Analytics hits isn't a materialized view. It's not storing that data in a new table. It's just a parsing endpoint. And then we do have some materialized views. So each API queries specific materialized views optimized for single dimensions. That's correct. So like top pages queries this. And I think like locations, browser, and device query this one, and then sources query this one. Filters are applied at the materialized view level, limiting flexibility. So phase one, create a unified base query node. Interesting. It's going to create a base node. I guess that would work. And then it's going to update each API endpoint to query that analytics base. This is interesting. This is a path. I actually think, well, you know what? Let's roll with it. I think this could work. Another route we could take is basically say, hey, well, maybe we implement those filters just on the analytics hits instead of creating another shared base query. But let's do that. I think that's okay as a kind of a next evolution. But then it's going to sort of add these filters. So it's telling me how it's going to do that, how it's going to update the endpoints, standardized parameters. Okay, we've got implementation steps. Okay, and then performance optimization. So hybrid approach, instead of completely replacing materialized views, use a hybrid approach. So actually, this could be something we do now. Use materialized view when no cross-dimensional filters are applied. Fall back to raw data queries. I actually think I'm going to tell it to just go start with phase 2. And in fact, let's just say, hey, no, I want you to start with the hybrid approach as a first phase. So basically what this will do is it'll leverage the existing materialized views we already have, but then it can fall back to that raw data filtering when, or that raw data querying when we add cross-dimensional filters. This will work. This, hopefully give us a working functional thing. So let's just tell it that and let it go and kind of take that feedback and yeah, hopefully we'll get a private or a hybrid thing working. By the way, I should have mentioned, I didn't mention this, but Tinybird local is what I'm running all of this on. This is all running in a Docker container. I'm using OrbStack. You can see Tinybird local here. I think I've only allocated like 2 gigs of RAM to this, so you probably would want more than that, but I'm running a lot of things on my machine right now, and Tinybird gives the marketing guys the low RAM MacBook. So what can I say? But yeah, like 4 gigs, 8 gigs. So if the queries seem a little slow, that's because I'm not really giving this a lot of memory. But the nice thing is that it's running everything. Tinybird is running everything locally. So you get the ingestion layer, you get the database, you get the API layer, you get the tokens, you get all of that stuff running locally. Okay, so it has updated the plan. Phase 1 is going to use that hybrid approach. So just a reminder, like what it's telling me it's going to do: use existing materialized views when no cross-dimensional filters are applied, and then use raw data queries when cross-dimensional filtering is needed, and then kind of have this sort of decision logic built into the API. So let's let it run through this plan. And the nice thing is, now we have this. Let's close these. We have this. Well, we haven't created the. Let's create the plan.md file. Okay, so now we have this in a markdown file. Great. So if our session ends, we at least have this as a backup. So plan's created. That's great. All right. So would you like me to? Yes. Oh, I don't want to open that. You want to be here. Yes. Proceed with the hybrid plan. And let's just focus on the top pages API for now. So I'm just going to focus on one API, kind of contain the work that we're doing, validate that the path that it is choosing will work. Okay, so then Tinybird code, given that prompt, is telling me what it's going to do. So it's going to create this shared filtered analytics base node for flexible path queries, update top pages endpoint with hybrid logic to use materialized views for simple queries, and raw data for cross-dimensional filtering. Makes sense? So we can do, yes, continue and implement all. We can basically just say, go through the whole plan and do it. I'm going to control it step by step, just so we can kind of have a check in there. Pull this up so you see it a little better. So Tinybird code is going to go and kind of implement that strategy. It's interesting doing live coding with AI agents. It's not really coding, but this is, how a lot of us are working now. So you can see Tinybird code. Here is this filtered analytics base.pipe. So it's creating this shared base query for cross-dimensional filtering. Personally, I would have reused that analytics hits endpoint, but I'm not going to argue with this for now. You can always come back and optimize it later or point it in a different direction later. But you can basically see what it is doing is it's pulling all the data that I need from that analytics hits endpoint, and then it's adding all these filters. So when we want to filter by device, browser, location, path name, referrer, it is adding all of those filters, and that's it. That's kind of encapsulating all of that logic into a single pipe. So we'll let it do that, and you'll notice that. So one thing that Tinybird code does is anytime it creates a resource, it immediately builds the project locally. and it does that to check for errors. And so you can actually see it got an error that the nodes can't have the same name as the resource. I don't know, it should know this, but hey, update the prompt. We'll ship an update, I'm sure. I'm sure Rafa's already shipping an update for this right now. But it's just renaming the nodes. You can see that in the diff. So we're going to update that. It's going to build, and then it will validate the build. So the build has been validated, so that base pipe is done, and you can actually see it over here in our directory. So we now have this pipe file here, and it is built and deployed on Tinybird local, so I could go and fetch that API locally and get a response. So now it's going to work through the next phase of this plan. And I guess what it's now probably doing is going to update this top pages endpoint. Okay, so this is what it is doing with the top pages endpoint. And it's going to show me this whole diff, updating the description. So it's kind of, so this is actually really, this is an important point. One of the things that I love about Tinybird and the way that you define resources is that it's perfectly optimized for AI-based, work, because every pipe, every SQL query, and every node has a plain text description. Actually, every resource, every data source, everything has a plain text description. And that description is really, really useful for LLMs. So you can provide really detailed and rich information there for an LLM. So it's great for discovery. If you're using the Tinybird MCP server, you add that description into your API endpoints, and now the MCP server, makes it easier for the agent to discover the right tool to use, things like that. So it's just a nice little thing that you don't really notice much. When Tinybird was being used mostly by humans, people didn't really fill out descriptions much unless you were working on a really big team. But now that people are working with LLMs, it's like, yeah, definitely want to add them. And of course, the LLMs generate them for you, which is really nice. So let's see what it's doing. So it has these cross filters. So it's basically checking. Interesting. I don't know if this is going to work. I don't know if this set, I don't know. We'll see. We'll see how it works. But basically it's going to, so if not has cross filters, so here's what it's doing. It's saying, if I'm not trying to cross-dimensional filter, I'm going to pull from that materialized view. If I do have cross-dimensional filters, I'm going to pull from that filtered analytics base that we have. I'm going to do that raw query and group by path name. And then it's going to kind of do the same thing on my previous data. So remember, we have two nodes, one for current, one for previous. And then, yeah, so then we kind of add this into the endpoint. All right, let's continue. And we have an error, unknown operator, end if. Yeah. Tinybird just uses end, not end if. So the LLM kind of made something up here, and I'm sure it will get it right on this fix. This is, there we go. Okay, yeah, see, it recognizes a mistake, goes back to end. All right, so let's update it, and it's going to build. We have another syntax error. Oh, interesting. It looks like we have a syntax error in the something. So the nice thing about Tinybird code, like in the LLM, it makes mistakes. It takes the error information that you get from the build, and it will attempt to rebuild. So I'm going to let it try to do this itself. There we go. Yeah, so I think it's abandoning the whole set concept, which I think is the right move. In Tinybird, you have this ability to kind of set parameter values. And I think maybe the LLM got a little confused there. So now it's going back to that if defined filter logic, or that logic, and it builds. Awesome. So that's a great thing about Tinybird code. It will make mistakes. It will kind of take those error messages and rebuild. And let's see what this, okay. So now we have this, endpoint, and actually I'll just tell, run a test query for the paid, or run a test, request on top pages with cross dimensional filtering for data in the last 7 days. So I'm just going to let Tinybird code do the dirty work for me and make a request to this API, pass those query parameters, so we can kind of see that we get a response. And after this is done, I'm going to tell it to sort of implement it across the other. Where should this? Okay, so yeah, this is another thing. Tinybird code is, we're obviously dealing with a local and a cloud environment. So anytime Tinybird code is unsure about the environment, one, it will default to Tinybird local, but it will also maybe ask for context. So instead of querying from cloud, I haven't deployed any of this. This is all running locally. So I want to execute this on Tinybird local. Okay, so there we go. It called this pipe with the parameters device filter, desktop, browser filter, Chrome. So basically just said, here are the visits on this, visits and hits for Chrome users on desktop. Okay, so it seemed to have worked. So now I'm going to tell Tinybird code, now implement the same logic for the remaining APIs. So let's go ahead and let it continue working through that plan. And in the meantime, and I'm just going to say yes, continue, implement all. I'm just going to kind of not babysit it. In the meantime, let's let Cursor go to town on this dashboard and update the front end. And so again, kind of going back to the front end, I want to update this so I can click on these things and it will apply those filters. So I'm just going to tell Cursor I'm updating my dashboard so that I can click on any value in the top X components and it will filter the data based on that value by passing the value as a query parameter to the Tinybird API. I want you to implement a click to filter feature on the dashboard so that when you click a value, it adds it to the filters and displays the filters at the top. Something like that. In my experience, this has been mostly a one-shot. We'll see. I'm using Claude. I'm using Claude Sonnet here. Best coding agent, or best coding LLM in my experience. So it's going to help me do this. So this is a good kind of way to point out. This is how the Web Analytics Starter Kit is structured. You have the Tinybird project. You have the middleware. So you have kind of these API routes. Okay, yeah. So this is for the tracking script. So if you put the tracking script on your website, you obviously need that to send events to Tinybird. And then you have the dashboard, which is this Next.js app. So that's what we're asking Cursor to focus on, is just this Next.js app. So actually what Cursor is now doing is it's looking at my Tinybird project structure and it's figuring out how to modify the front end to support those filter parameters that we added. And let's see. So it's going to create a filter state management system using URL search parameters. That's what I want. If we go back to Chrome, you can see that's how it's implemented. We add all those search params in the URL, and those filters get applied to the APIs. And by the way, feel free to critique my front end implementation here. This is not a React tutorial. We're doing the quick and dirty here. They probably won't let me merge this into main, but we'll see. We'll see if I can get away with it. Okay, so blah, 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 blah. So it's implementing this. So it'll take a while. Tinybird code is still kind of working through updating all of its endpoints. Should actually be finishing up pretty soon. I think it's done maybe all of them except for the KPIs endpoint. Yep, so now it's working on that. This one is a little bit trickier. It has kind of a different structure than the other. So I might. Okay, so it built. Just because, by the way, just because an API builds doesn't mean that it's valid. It just means that it runs. The syntax is valid. It will return a response. We'll see if it actually, works. We might have to do some troubleshooting here. I'm hoping we don't, but we might. That's part of it. Victor, no, I will not let you merge that. It's protective over his code base. That's fair. Yeah, it's the idea that counts, Victor. It's the thought that counts. I know that you're going to take this incredible stroke of genius that I've been working on here, and you're going to make it actually production ready. So thank you for doing that dirty work for me. Okay, so boom, Tinybird code is done. So that means that all of those APIs should now, in theory, support cross-dimensional filtering. Cursor still working through the front-end changes. You can actually see, so it added a filter display component. That makes sense. Something to show the filters. It's updating this pipe table. Yeah, okay. Component to make those clickable. That makes sense. And then it's actually going through all of these components and adding this use filters hook. So actually, I guess it probably added that hook. Yep. So it added this new use filters hook, and it updated the use endpoints hook to support those filters. So pretty vanilla stuff, and it should hopefully be wrapping up pretty soon as it makes its way through these components. Okay, so it's continuing to update components. And actually, I mean, this is all happening live. We're running a next server. Yeah, actually, you can see now these are clickable, except for top browser. Oh, there, it just finished top browsers. Okay, I guess it's probably done. Let's check. Integrate filter. Okay, now it's going to put that filter display component in. So let's let it do that, and then we'll see if it's done. Final to do. Running its checks. Always has to check the lints. All right. It's got linter errors, of course. Okay, it's going to fix those. But basically it's done. So I'm going to go ahead and try this out. Let's see if this works. So if I click blog advanced tips, okay, we were close. So these components all worked. So the top pages, top locations, top sources, top devices, top browsers. You can actually see it's only showing that blog. We filtered it down. We have 4 visits. You can see all of these add up to 4. So that worked. But this did not work. So we're going to need to help Tinybird code figure that out. But it's nice. We have this little component here. Drop that off, and it's going to do that. So, I mean, in theory, I could click blog advanced tips in Brazil and kind of get this cross-dimensional filter on these components. So that worked. Let's go and troubleshoot this KPIs one. Figure out what happened. Okay. Yeah, we can keep all. So let's go back to Tinybird code. And let's see. I want you run a test API request to the KPIs endpoint with path name equals, let's just use that example that I just did. Blog.advanced tips, whatever, I'll just type it. Blog advanced tips and check for errors. I'm just going to ask Tinybird code to make a request to that endpoint. The error that I'm getting, we can actually go and see this in the network tab. If we click on this KPIs, it's all of identifier. So interesting that this request is actually giving a response, but this request, so the one that includes the previous period fails. So that actually could help us. No, you also, it seems the KPI's endpoint is not working when, what is that? Include previous period equals true. And if I can't figure this out, I'll just take that error that I'm getting in the front end and just provide that as well. There we go. See, okay, so it now has an error. So it's called that endpoint using that what I provided, and it's seeing that error that it gets. So that's the nice thing is, Tinybird code can hopefully take this error. It's unsupported method, so unresolved identifier date. Okay, this hopefully will be a relatively simple fix. That is one of the things about when you just build a project. Again, it's just checking the kind of the syntax on the default. So it's not actually like if you run a deploy, I'm pretty sure that the deploy is actually checking, all the different query patterns to make sure that you can deploy without breaking something. But the build is just kind of checking the default. And so the default for this is not to include previous period data. So it built just fine. But then when we tried to pass a certain query parameter, it failed. So let's let it. All right, so it's going to, let's look at the def. Okay, so, oh yeah, all it has to do, yeah, okay, so I guess it was trying to use a date that didn't exist. Honest mistake. So let's let it update that. Okay. And now, maybe this will work. There we go. It wasn't fast, but it worked. Okay. So we now have a functional, working, sort of cross-dimensional filter. It does not seem to be very performant. And so that would be kind of our next step. So if I click this, we can actually go, look at the network tab, and we can see like, here, let's figure this out. We'll just say, go fetch the last 30 days with this cross filter. Yeah, 300 milliseconds, that's actually not bad. If I pull that off. Yeah, okay. Add another one for the last 30 days. Okay, so this is not, these hot queries aren't too bad. 300 milliseconds, not great. We also only have 100 or 1,000 rows of data in this data source. So that's really not a lot. We're also only operating this entire, Tinybird local on 2 gigs of RAM. So that's another thing. But let's try something first. Let's add some more data. So just kind of stress test this a little bit. I have a little mock data generator script that I added to this just kind of for simplicity. It's here it is in this little scripts folder. I have this generate mock data. So I'm just going to node. Let's go to Tinybird. All right, mock data, and I can add this P. So let's do 1 million page views, and I'm not going to generate any core web vitals data. This might take a little bit of time, not a lot. This is my favorite thing with vibe coding because I work in data all the time. I should mention, Tinybird includes a mock command in the CLI, and that usually works really, really well. What it can do is it can generate mock data based on the known schema of a data source. The only challenge can be when you are dealing with these sort of semi-structured data sources where you have like a big JSON object and a column, is that, theoretically, the data it builds will work, but it might not parse correctly in the endpoints because it might not populate that payload correctly. You can basically tell the TB mock command with a prompt like, hey, this is what that payload structure should look like. rather than, futz around with it, I have found that, you can vibe code a generator script like this and it takes about, 20 seconds. So that's what I did. So it has created this, where did it put it? Oh, it created a new Tinybird file. That's not what I wanted here. Put it in this fixtures folder and get rid of this extra little folder that you created. Okay, so it created this new JSON fixture. It has 1 million rows. So yeah, so okay. So you can see. So we are going to append that. TB data source, append, analytics events, grab that file, and we're gonna send that data to Tinybird local by appending it to that raw analytics events data source. So it'll take a little bit. Again, it's a million events, and it's gonna kind of do it all in one go. Shouldn't take that long, but it will take a little bit of time. And let's just, we'll wait. Server error. Yeah, it happens. I guess cursor lost connection to my. Oh, you know what? Did I take down orb stack? Oh, I think I took down my my Docker container. Okay, let's bring it back up. We might have to restart Tinybird local. I did this before and it worked fine. TB local status, let's just see. I would imagine that it is down. Oh, no, it's ready. Could not retrieve the workspace info. Yeah, okay, so it's in kind of a bad state. So here's what I'm gonna do. I'm gonna TB local restart. It's actually gonna clear out all the data. This will take a little bit. Yeah, I'm sure. Sometimes this happens when you're working with container. The container gets into a bad state. I probably just kind of, overdid it. I am not going to download the new version. See, I told you that Rafa was already, I just updated the version. I knew that he was working on a fix already. This happens often when you're working with Tinybird, is you realize that we ship all the time. Lots of downloading new versions because we're constantly shipping. So while we wait for Tinybird local to be ready, let's see, what should we talk about? So we've implemented this basic filtering, and it actually, I think the performance is going to be okay for 1 million rows. Yeah, Victor, that's true. You also realize that when you work with Rafa. Yes. For those of you who don't know Rafa Moreno, he is the GOAT. He is, he's the guy when it comes to Tinybird code, Tinybird local, the MCP server. He's really leading the charge there, and he is amazing, cracked, and he ships fast. So, all right. So Tinybird local is ready now. If we go back to the front end, you're going to see we have an error, and that's because this token is no longer valid because we restarted the environment. So I'm going to go back. It's going to prompt me again for that token. I don't even know. Yeah. Okay. So we're just going to get our token from the CLI. So tbin token copy admin token. That's going to give me that workspace admin token. I can paste that in here. And it's going to say, well, it doesn't exist. Well, that's because we haven't built it. So we'll just tb build. Again, taking those resources, building them locally. And it is actually, when it builds, it's going to use this, it defaults to using the fixture that matches the data source name. So it's going to build it with these 1,000 events. So if I go back, it should have that data. Yeah, those 1,000 rows. So we're back to kind of the state we were at before I tried to shove 1 million events down its throat. I'm going to try again. Let's see if it'll do okay with it this time. And if it doesn't, maybe I'll break this up and do a few 250,000 events or something. I haven't done this before when I'm running all the streaming stuff, and again, they gave the marketing guy the 8 gig MacBook. So I'm working with what I have here. Hopefully we don't kill Tinybird local again. And again, the reason I'm doing this, I'm adding a little more data to my local environment. There we go, rows appended. Okay, so now if I go back to the dashboard, show the last 30 days, it's gonna show, boom, it's got all this data. And remember, I appended 1 million page views, but those have different tenants. I think maybe there are 3 tenants, which makes sense that this tenant has 1/3 of that data. And so, you know, and we can filter by domain, right? And that's gonna filter it down even further. But let's just go back to all domains and let's just see, let's look at here. Let's clear the network tab. If I go to 7 days, we can see, yeah, so I mean, still those APIs are actually performing pretty well. So if I go to 30 seconds, so, you know, we're getting into that, okay, we're starting to get where it's like, yeah, 500 milliseconds, still pretty fast. But you can see how it's crept up, right? I think like as we went from 1,000 rows to 1 million rows, the latency, I guess, roughly doubled. Yeah, I mean, the hot queries do a little bit better, but you can see like that's not what we want. Is that no matter how much data we throw at this thing, we would get the same, same performance characteristics. And that's where materialized views are going to be really useful. And there are a couple of strategies that we can use here. One is that you can, we can create a lot of different materialized views to support the different filter patterns that we have. That is one way to do it. So, can kind of provide those aggregates for all the different ways that you can slice and dice it. That can become kind of inefficient, especially kind of inefficient with storage. You're basically just reformatting your data, and restoring it, basically storing it in a different format to improve the performance. And there's another strategy though that I think we could use that I think would really help us, which is to aggregate, to basically do roll-ups. So materialized views are a great way, and this is a great pattern for dashboards like this, is to use roll-ups. So you can see that when I'm selecting, 7 days or 30 days, it's showing me daily aggregates. But what is actually happening, this query is actually going and it's doing those daily aggregations on the fly. So it's going into the raw table and it's aggregating these things by day, with these filters applied. Yeah, I actually didn't show, that was just the query, the optimized query. Let's actually look. Let's see how this gets when we have this these cross-dimensional filters. Yeah, okay, so now these are taking a while. Okay, so 2 to 3, about 2, maybe 3 seconds. That's not good. But what we can do is we can pre-aggregate. So right now, I'm looking at the last 30 days and I'm filtering by page. And since the raw data source is not sorted at all by this, I'm probably going and, fetching, probably close to 300,000 rows or something like that. And it's parsing through that logic. What I could in theory do is pre-aggregate so that, I have daily aggregates for all of these different things. That'll really, really minimize the amount of rows that I need to, probably by an order of magnitude or by several orders of magnitude. So I think that's a good strategy, and we're going to try that here. I've got time. Let's go and give that a shot. So what we're going to do, I'm actually going to open up. Let's look back at the plan. Let's look back at the plan that Tinybird code created, and let's see if it said anything about. Let's see, implementation steps. I love how LLMs do this, that they give you this time range that you're like, don't worry. In the first week you'll do this, and the second week you'll do this. Like, you don't know how much time I have. I got a few minutes. Come on. How about hour or two? But yeah. So okay, phase 2. This was month 2. We're doing month 2 right now. multi-dimensional materialized view. So actually, that's how this one wanted to do. That's how Tinybird code wanted to do it. Create an optimized materialized view for common cross-dimensional queries. Okay. This is a path. This is a path that we could take. Add a third path. Yeah. This is a path that we could take, and it's basically going to say, like, I think that most people will want to look at specific path names and then filter by something else, or, you know, I don't know. That might help. Exclusion, man, it's got, I mean, it really, so here's what I want. Here's what I'm going to do. Let's go back to Tinybird code. I want to see, let's see, I want to optimize these APIs. Click cross-dimensional filtering works, but it's pretty slow. Let's start by using a rollups strategy to pre-calculate aggregates by day, so that when a user selects a time range, of 7 days or greater, we can select from those aggregates. Yeah, I mean, I think that should work. I mean, yeah, I think that's relatively clear. And if I were actually doing this, I'd probably tell it to create another markdown file. I'm not going to do that because we're an hour in, and I think we can just roll with this. And it's going to go ahead and, I mean, it will give me its plan. It will show me what it intends to do. Okay. Great. Excellent optimization strategy. Thanks, Tinybird code. Let's implement a rollups approach to pre-calculate. Yeah. Okay. So it's going to do that. Create daily rollup materialized view with all dimensions. That's what we want. Create a materialized pipe to populate it. Use the filtered analytics base endpoint to use rollups. Yep, update. So it's going to update that base endpoint to use the rollups instead of the raw data. And it shouldn't actually need to update all endpoints, but let's see. Let's go ahead and continue. Okay, all right, so this is what it's going to do. It's going to create this analytics daily rollup MV with a date, tenant ID, and then all of those dimensions, and then aggregating the visits and hits. That's exactly what I want. And then you can see that it's going to sort by all of these different things. So again, like, in theory, like, I don't know if you'd create an MV for each tenant. That doesn't really make sense. You could maybe do it for each. Well, no, you really couldn't. Those are sort of high cardinality things if you're dealing in a multi-tenant environment. But yeah, multi-tenancy complicates things. But we're going to roll with this for now. So yeah, let's create that data source. So Tinybird's going to go and build that data source. Here it is, analytics daily rollups. It's built that. That is now a table in our database. And now it's going to build the pipe to populate that. So let's see what that pipe is doing. It's pretty basic. Selecting the things from analytics hits, grouping. Yeah, and then it's just doing these aggregate functions. It's storing the aggregated state, unique state session ID as visits, count state as page views, basically as hits from analytics hits. So it's fetching from that raw data using the parsed endpoint, and then it's grouping, and it's going to materialize that into the daily rollups MV. So what it's going to do is this happens sometimes with materialized views. Basically, we can have an issue where we get into a bad state. So actually, I'm gonna cancel this. I'm gonna go back to using just 1,000 rows of data just to take things a little easier on my local. I have found that when you get this error, clearing the workspace helps. Kind of resetting things. So we're going to do that, which means we're going to have to build it again, which is fine. and it's going to use just 1,000 rows, which is fine. We're implementing a strategy. We can stress test it later. By the way, I didn't run those tests. Maybe we can do that at the end when we're done. Okay, and then I'm going to get TB token, copy, get that admin token again. Go back here, refresh without the stuff, paste my token in, and hopefully, okay, we're back. Now let's go in here, and I'm gonna give it this, okay, so it's already created. So we already have this materialization, and actually, okay, so it has already built this pipe. Okay, so it should, so let's just see, TBSQL select count from, what is it? Analytics daily rollup MV. Oh, not MC, MV. Boom. Okay, so it has calculated these daily rollups. Now, interestingly, we have 1,000 rows, which is the same number as the raw data. So maybe the strategy won't work. I'm curious if it would work at scale. It might be that my raw data is so random that it's not, it's not providing any performance benefit. It might be that I have like one data point per day per all of these things, which would not be typical, but that might be the way that my mock data is set up. So that's, maybe would help. Let's just see. Let's try appending the TB data source. Let's try appending those million rows again. Analytics, events, fixtures. And I want to see if we still have the same number of rows in the materialized view, because if we do, then we're not going to get any performance gains. The goal here is to have to query fewer rows by pre-calculating the aggregates. And I would expect in normal circumstances that you would have, you would get some benefit here in a realistic environment. My mock data might not reflect that, or maybe that's not true. Maybe I'm not thinking about it right. But that's kind of what I'm hoping to see. So what it's going to do, what Tinybird is doing, is appending those million rows to that data source. And as it's doing that, materialized views in Tinybird, quick primer, in case you're unfamiliar with materialized views, I've been talking about them. Materialized views are, operate on an ingest trigger. And so what they will do is when new data hits the data source that the materialized view is querying from, that triggers the materialized view. So it's going to pre-calculate those aggregates on ingestion, and it stores those aggregates in sort of these temporary aggregate states. And then in the background, every few minutes, it merges those aggregate states into an aggregate, and that kind of continues to happen. You can force that merge process to happen as well when you query. And so you kind of use these, you see these, it's stored in the table, not as an integer here, but as an aggregate function. So then when we query it, like if we go, let's go look at an endpoint, top pages from analytics hits, where's an MV? Here we go. You can see it's using this merge modifier. So it's doing that final merge in the query. But basically by pre-aggregating and doing that merge process in the background, we significantly reduce, hopefully, the amount of data that we have to process, because we're only processing it once during ingestion rather than 1,000 times when all of our users are querying that endpoint. That's a very elementary explanation of materialized views. Our documentation has a lot of good explanations about it. So rows are appended to the analytics hits or analytics events data source. Now I want to get the same. Where's the command I just called? TBSQL. I don't know. Okay, let's find TBSQL select count from analytics daily rollup MV. Hopefully this is less than 1 million. A little bit, not a lot. Okay, so this strategy probably wouldn't work very well for this data. I mean, you can see, so if we, if we change this to analytics events, that has, so, okay, we saved 70,000 rows. That's not going to, we're hoping for orders of magnitude here. And I'm pretty sure that's because, the way that my data is structured is it's like kind of random. It's not using realistic patterns where you'd have many users. Let's say like you put a post on Hacker News and it goes viral. You're going to have many users that are coming in, through Hacker News to that path name using a particular device, and all of that kind of gets collapsed into one. In this case, that's not happening, and that's why we're not going to get a lot of performance gains there. So let's. I mean, I think we should abandon that. I don't think that's going to work. Let's start Tinybird code again. I guess I shut it down. Okay, so let's go back to. Let's let Tinybird code cook here. Let's. I want you to optimize the top X endpoints and the KPI endpoint. They currently support cross-dimensional filtering, but they are not efficient as data volume grows. First, suggest some optimization strategies. Let's just start here. I know it already did that in that plan.md file, but we're gonna start fresh just to see, just for fun. All right, so okay, so here's what it's gonna. Okay, pre-aggregated cross-dimensional views. Yes, that's what we've talked about. Hourly rollup for real-time query, specialized use for popular filter combinations. Yeah, I mean, I think this is, this is ultimately, I think, what it comes down to. And actually, this is a huge benefit of Tinybird code. When you start to deal with this, cross-dimensional, multi-dimensional filtering, a lot of times the way that you optimize is going to depend on your data and the actual data that you have. In my case, based on this raw data or this mock data that I generated, like using daily rollups didn't actually help that much. Maybe weekly rollups or monthly rollups would have helped. I think that it would in most cases, but in my case it didn't. And you can also create specialized views for popular filter combinations. And I think, that would make a lot of sense as well. And the nice thing about Tinybird code is it not only has access to all of these local resources, like it can look at how you've structured your data pipelines, but it also has access to your performance data in prod. And so it can actually go in and look at, we call them service data sources in Tinybird. It's basically logs of, requests people have made to your endpoints, things that have happened in the data source, and Tinybird code can access those things. You're authenticated. So it's going to go and it can say, hey, I can look at your query patterns over the last 30 days. And I can say, hey, these are the most popular patterns. I would recommend optimizing it this way. Or, these are the APIs that have shown the, biggest performance problems. Here's how you could optimize those. And that's really, really powerful. That's a really, really powerful thing that, that Tinybird code can do. And in fact, let's just say, I'll just say, hey, look at my request logs. It's not really called that, but just look at my request logs on Tinybird local and get a baseline for endpoint performance stats and suggest how I might improve them. So again, I haven't deployed this to the cloud, but I could, I'm just going to point it at Tinybird local and say, hey, look at the query log of things that I've been doing locally as I've been developing, as I've been, refreshing this dashboard. Yes, execute this on Tinybird local. So you can see, here's what it did. Pipe name, request count, it's getting all of these stats. Look, and it even added this filtering, when pipe name like blah, 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 then priority, else other. It's telling me my endpoint category. And it's querying this pipe stats RT data source. This is a service data source in Tinybird. It stores all of these logs. It is free to query. It doesn't cost you anything to query these. It's really great for building like observability APIs. You can plug those into Grafana really easily. And so what it's doing is it's running all of these queries and it's showing the results. You can actually, I mean, this is not very well formatted. Let's see if I can, yeah, that's not great, Bob. But it has arrived at some findings based on actual data, actual real requests and their performance. So priority optimization targets, the KPIs endpoint, critical priority, average is 640 milliseconds, P95 is 1300 milliseconds. Okay, issues, highest volume plus worst performance combination, root cause, complex session level aggregations across time periods. So this is great. Tinybird code is able to go into and look at my data, look at my production environment, look at the API requests that are actually being made and make recommendations. That's really valuable. I think it's really valuable. And it's actually even, sort of prioritizing things, learn from top sources. Okay, this is interesting. And this makes sense because I think top sources, top pages, those endpoints, they use that. They're not using session-based aggregation. They're using event-based aggregation. So it makes sense that they perform better. KPIs endpoints, reduce cross joins, time-based partitioning. So there's a lot that we could do here. I think we're out of time for today. I think we'll have to follow up on this. I'm not going to merge this to main because Victor's not going to let me. But the cool thing is we did implement the feature that we wanted, and for smaller data sets, this works pretty well. As the data gets larger, it's not ideal. But it's let's see. Let's go to example.com. It's still relatively performant. Like if I were using this just for my own internal analytics, I could probably get away with this. It's not as fast as I would want it to be, but it's not terrible. So yeah, we did it. We did cross-dimensional filtering. We talked about some performance strategies. Oh well, something broke there. I probably took down Tinybird local again. 2 gigs of RAM. Anyways, that's it. By the way, the Web Analytics Starter Kit, if you want to do something like this for yourself, it is a template. It's open source. You can go clone it right now, go fork it, go deploy it on your own. If you want to just use it, for yourself, tinybird.co/templates. You can find it right here, the Web Analytics template. All you have to do, log in, deploy the template, and then basically paste a tracker script on your website and you're done. That's it. That's all it takes. Very, very easy to deploy this and start using it for your own website. And yeah, just a reminder about the next build next week. I think September 4th is Thursday. Javi Santana is going to ingest 1 billion rows per second into ClickHouse. He's going to show you how to do that. He's going to talk through some of the scaling strategies and performance strategies for ClickHouse. They'll be much nerdier than this one in the best way possible. Santana wrote a blog post about this, by the way. It was very well received. It's very interesting. Go to our blog, check it out. You can find it. And yeah, subscribe to the YouTube channel. We don't collect emails or any registrations for these. It's just you subscribe to the YouTube channel, you get notified on the next one. So go ahead and subscribe. At the end of the day today, I'm going to go and I'm going to look at all of our new subscribers, and whoever subscribed is going to get a code hat. There's no branding on this. It doesn't say Tinybird anywhere. I'm not trying to market to you. It's just cool, high quality embroidery. So go check it out. Go subscribe to the channel for a chance to win this hat. And then I'll just DM you on YouTube and tell you how to get it. Thank you. Thanks for joining us. If you have any questions about Tinybird, or you want to, if you need support, you can go to tbrd.co/community. That is our Slack community. You can join our Slack community. It's a really active community where people ask questions about Tinybird and get answers. We're really active there. We really try to support. That is something Tinybird is known for. We provide friggin' awesome support. So you can go to that Slack community and ask questions. If you do want to get started with Tinybird, it's free. There's a free plan. It's free forever. There's no time limit. There's no credit card required. Just get started building. And you can kind of have your first proof of concept up and running probably by the end of today if you started now. So cool. Hope you have a good one. Thanks for joining. We'll see you next time.